So if v squared was equal to 2gh, that's exactly what we would find using basic kinematics, right? So that's a consistency check that's good to do here. Our answer makes sense, okay? So now we have part B to worry about. We solved for v, which means we also have omega p and omega d, so that's no big deal. Let's worry about part 2 here, which is to find the acceleration of the mass without resorting to Newton's laws. Can anybody come up with a way to do that? Yeah, some calculus is probably going to have to go on here. Yeah? I don't necessarily think. Well, the problem is I think that we're not sure yet if the acceleration is constant. And that relationship follows from one crucial piece of information that is given in this problem. Can anybody tell me what the crucial feature of these pieces of information that I gave you? Which one of these is crucial so that I can find a relationship between the omegas and the v? No slipping. That's right. If this rope could slip, then I would have no idea how to write omega p and omega d in terms of v. All right. So if you haven't found that relationship yet, think about it a little bit longer, maybe a minute, and then we will wrap this problem up.
So part C is asking, is the tension the same everywhere? It's not. Why isn't it?
Well, because if it was, then that would be 0. Because we'd have T1 minus T2 RV, and that would be 0. So
Exactly. Because now the pulley is rotating. Okay, now tell me for point mass. What will be the angular momentum for point mass? What will be I? mr squared. What will be omega? If this is r, this is v, then omega is like this, right? What is the relation between omega and v? Right. So we'll have v over r. And you can see that these two will cancel out. You will have mrv, right? And it will be the same thing as here. You see that? Yeah. So it's just basically the same thing if you have a point mass. But this is where moment of inertia comes into account. If it's not a point mass, if it's a complex object, then you can use the moment of inertia here to find the angular momentum. Okay? Any questions about this? Okay, let's do question 41 because this is the only example on the